Hi there, welcome back to the channel. Welcome to the third video in the restoration series of this Graetz Melodia 519. When I left off in the last video, you probably noticed I was a little frustrated. Things hadn't quite gone my way. Murphy's Law had stepped in and everything that could go wrong went wrong. Probably to do with a little bit of stupidity on my end, but hey, it happens. So I'm happy to report that that's not the case in this video. Things actually went very, very well, although I did find a few quirks along the way, some actual broken pieces that needed to be repaired, and quite easily done, but it was interesting. And finally, the actual alignment of the AM-IF and the FM-IF. Now, I was a little surprised when I started doing the FM-IF alignment because normally I have a routine, I go through it, I go into it almost without thinking. This time I started doing that and realized that that actually made it simpler. They made it a lot simpler to do the FM alignment because they actually make the contact points accessible to the back of the chassis. This is not the first radio I've seen that in, but it's rare. So this was actually quite simple, and I'll show you exactly how I go about doing that alignment per the instructions. Another thing that I'd like to point out is some of the really well-designed sections of this radio that make accessing difficult parts very, very easy. So if this sort of thing interests you, stick around, enjoy the video. Before we carry on, I just want to thank the sponsors of the video, PCBWay. You'll find them at pcbway.com. And as we go into December, they're running their Christmas sales. Here you'll find some amazing offers, both on PCB prototyping, assembly, rigid flex, advanced PCBs. Also, if you want 3D printing or CNC machining, you've got some amazing offers here as well. And they're also running a lucky draw, where you click on a box and get some goodies. And I don't know whether you know it or not, but they've also got a store where you can get some amazing modules. So whatever it is you're looking for, whether it's for Christmas or just for your normal projects, go to pcbway.com. I'm sure you'll find something for your needs. I wanted to get on with cleaning the front of the radio, and I decided to use my airbrush again, which I don't fill with paint, but rather with isopropyl alcohol. There it is sitting on the floor there. It's just a little airbrush compressor, and I use it as if I was painting, but instead of using paint, I use isopropyl alcohol and then rub it down with my bristle brushes, and everything sort of comes loose. And the advantage is that I get to sort of wash away the gunk as it gets loosened. Now, the problem usually was I used an incredible amount of cotton swabs and all sorts of things to get rid of the dirt. Well, in this case, I just rub it off. In other words, break up the dirt and then just let it run down. You've got to put something underneath because it really gets gunky. And as you can see, it comes out pretty well. You've got to be careful with this though, because I had to test this before. In some cases, the alcohol actually dissolves the paint. In this case, I know that it doesn't because I tested on a small section. But you can wash everything down with the bristle brush. You know, you get right in there. You get various sizes of brushes. I've got, big one, small one, a long one. And away it goes. It just keeps going, and you see the results immediately. It's so gratifying. This is the sort of thing you want to do when you're bored or you're frustrated and you just want something that's meditative. That's what this is. And the result works out pretty well. Now, this is not shiny white, as you can see, but that is the state that it's in without dirt. This thing is, 60 years old or whatever. I'm ready to continue cleaning the top of the chassis, and there is a lot to clean here. There's a lot of dust, and it's sort of greasy, which makes it a little bit more tough to remove. But with the airbrush, it does a good job. But before I do that, I want to show you something really cool. Now, if you've done this long enough, you'll know that there are two components, two sections that are incredibly difficult to get into. One of them is the IF transformers. If you've had to remove the lid of some IF transformers on your radios, you know just what kind of an exercise that is. But I want to show you what they do here. It is so easy the way they've done this. You've got a clip on here. This thing comes in through the bottom. It's like a C or a U. And then you've got this clip on here. And I had to remove this clip because it was really rusted. But to remove this, you just push this down and it clips out. And you've got your clip, which I've de-rusted in the meantime. And now watch this. If I want to get in here, there's my IF transformer. And I've got full access to everything in here, which really isn't much, but it's that one coil former for the primary, and then the secondary. It's pretty strong, so it doesn't, it's not likely to break like some of the other ones. And you've got your two capacitors on there. You can see very clearly where they were soldered. There's another capacitor on this side. You can see very clearly where it's soldered. It's nice and tough. It's well built. And most importantly, you just remove the lid and you've got access to all of that. Now, this is really great. I mean, you do the same for the other one. And ta-da, there we go. You've got full access to everything inside. You can repair it if you need to. You can check those components down there. There's actually a resistor inside this one, which really is good to be able to get access to. But these are the most accessible IF cans I've ever seen. It's absolutely a breeze to work on. And as I said, if you've done this enough times, you'll know just how difficult it can be to open these guys up. Now, not only is that easy to get to, let me show you something else. I think the only thing that's more difficult to access than the IF cans is the FM block, usually. Now, this one, again, they've done a great job. These have got two clips on, one on either side, which you just lift up, and I removed these to de-rust them. And now watch this. That comes out, you can clean it perfectly, and you've got full access to the FM section, which in this case was crucial because I had the tuning capacitor, the tuning condenser of the FM section pretty tied up and gummed up and everything else. I was able to clean it up properly. I cleaned it with isopropyl alcohol because it dries completely once the alcohol evaporates. That's very important. You don't want to leave anything, any residue in the blades, within the blades of the condenser, because it does change the balance of the circuit. This is an RF circuit. It's very sensitive, very, very sensitive. So it's a good thing that you can get access to it without putting too much pressure on it, too much force on it. This is absolutely very, very well built, incredibly well built. And now when I want to put this back, it's just a question of, you got to choose the right size. That's the groove that goes into the tuning condenser. You just put it in like that, push it in, put the clips on, and it's done. I just thought I'd show you that. 3 sections that now can be cleaned outside of the chassis itself. And not only that, things that you can access very easily because sometimes you do need to get into them. I always try and avoid getting into the FM block, but in this case, it's not a problem. The problem with getting into the FM block I've found in the past is that everything is so sensitive in there that even moving sections of the cover can actually change the alignments. So the fact that this comes out quite easy without any pressure, without any force, is really a blessing. All right, let me carry on with this cleaning. There's quite a bit to do. I'll be going through quite a lot of alcohol, quite a lot of scrubbing, quite a lot of paper towels. As you can see, it does get pretty dirty down here. It'll get worse because this stuff is pretty bad. There's a lot of stuff on here, but nothing we can't handle. After a lot of airbrush compressor, lots of alcohol, this is the result. This thing is looking pretty good. The chassis itself has no rust at all. It was just grime and it was very greasy, so it took quite a bit of effort to get that out, but it's all out and I'm happy with the result. The aluminium covers for the IF transformers and the FM front end were cleaned outside of the case, obviously. That was very, very simple. Anything that's supposed to move, like those pulleys, that gets cleaned with alcohol, then gets lubricated because the alcohol just dries it out. So I have all the cleaning done. I've also done the underside, not as intensely because you've got to be very careful with the wires. But this is ready for the next step. And I discovered something, unfortunately, that needs to be repaired. This antenna socket, you've got these 4mm sockets for the antenna. That's the FM one. The ones for the AM have broken through. This thing's just flapping at the back there. This one's broken through as well. I think you can sort of see it popping out there. So I have to find a solution for this. And the way this works is actually quite interesting, but difficult to repair. You see, what it seems they do is they push this through. There's like a ridge on the back that clips to the back, and then they fold this or bend this, like rivet it out. And you can't really get this out because I have a lot of spares. That's not a problem. I've got a lot of donor chassis that I can use. And here's one of them. In fact, the diameter or the distance between the two, the spacing is identical. It's got a few more holes than I'd like. In fact, this top actually looks like it would be perfect for the FM. I might actually just do that because the socket will go through here. So instead of just cutting this, I might actually put this over the top, and then these would go through and into those sockets. That might be the better idea. Let me see if this fits. What I've done is I've actually removed the back completely. It's still soldered in there, but let's see if this fits in there. I'd have to make these holes a little bit bigger, but this might do. This might actually give me access to those guys. The alternative will be to cut a strip over here and put it over there. Even the width is wrong. I'd have to really cut it quite a bit and figure out a way to keep this in place. It's not going to be a problem. This is the phenolic, this is phenolic. So it wouldn't be a problem. And these you can polish because these are brass. But I don't know whether such a small surface will actually adhere very well. I'm going to see what's the best way to do this. I may well want to, in fact, do this. Except the other way around. Let's see, something like that. Nah, it's going to hit at the top. It's going to be best if I actually literally just cut this rectangular and then cut the right width and stick it over there somehow. Maybe screw it in. I can't rivet it because I don't have much space, but I think maybe there's some glue that'll hold this. Let me see what I can do, and I'll show you what I've decided to do, right or wrong. But it looks like this plan is going to work. This is still shiny because I've used some furniture restorer on it to get rid of the marks. It goes yellow on the edges when you cut it. So what I've done is I've cut this side edge here. I've cut this to the same width. So we've got this looking nice and uniform. I've widened those holes so that the FM dipole connections are visible and easily accessible. And now I'm going to glue this with probably contact adhesive. I think what I'll do is I'll mask off the top and sides just so that I don't get any contact adhesive where I don't want it. Should do it. You'll notice that all the brass is shiny because I've used the Dremel with a polishing wheel on all the rivets, all the sockets on this edge, on the back. Okay, that's sort of all right. That gives me a limit of where I should put contact adhesive so that I don't get it spreading out, and I've got to put it on the side as well, and then just push it together. Okay, this should be dry and ready to be pushed and pressed into place. I've always found contact adhesive kind of weird. To me, intuition says glue should be wet and then dry, and that's when it sticks. With contact adhesive, they say let it dry and then put them together. Well, looks like it's done. Okay, I'm glad I found that solution, and I like the idea of giving it more surface area to stick and hopefully stay there. I can always try a different type of adhesive if this doesn't work. I can always put a hole through the middle and actually put a rivet in there, although I would like to avoid that. When you rivet these things, you've got to be careful because it can actually crack. If you put too much pressure on the riveter, you can actually break the phenolic. That's not a good idea. But it actually looks pretty good. You won't ever even see this from the outside. Obviously now I just have to solder the wires to the back, and it's one more problem sorted. All right, you might notice that quite a bit of change has happened, namely the faceplate and all the knobs have been cleaned. Faceplate needed a little bit of touch-up on some of the paint. That is not unusual. Fortunately, it seems that the only scratches or marks were on the gold, so I used some gold paint from the back. Also, some of the tape at the bottom, which prevents the glass from coming in contact with the metal, needed to be replaced. Try not to take this tape off. If you rip this old tape off, you'll bring the paint with it. So it's looking good. All the knobs cleaned beautifully. Look at this. It's looking great. Okay, onwards. Well, I think I've got everything ready to do the alignment. I'm going to do the AM-IF alignment. And what I have is I've set the signal generator to 460 kilohertz, which is the IF frequency. The amplitude is set to a minimum. Modulation, 30%, a 600 hertz tone. And it goes to my pi attenuator, my switchable attenuator. I'm leaving it at 0 dB attenuation for now. And it then goes through the little socket that I have for the ECH81, which is connected to the grid, which means that I'm ready to go. And I've got the multimeter, my Simpson, connected to the output of the speaker. So if we put the volume up, we can hear a tone. It's probably too high, so I'm going to give it 12 dB of attenuation. Yeah, I don't want this too high. Volume's on max. But this is... Actually, I've just had an idea. Let me use my... Hang on a second. I want this to swing higher without putting the volume so high that it blows our ears out. So I'm going to use my multiplier here, which I did in a recent project. And we'll get it to see how that works. So the input is in here. I'm going to set this to off, so 2 times multiplication. It's going to double the voltage, AC voltage in this case. It's just measuring the speaker output. And I'm going to switch that on. And I'm going to put the volume up. Yep, that's going nicely, but I still want to give it a bit more. I'm going to give it 5 times. Okay, that's good. So I don't need to put the volume on max, but I can also just put it on, can you see that? That's a good swing. And I'm going to put this on dummy load so I don't have to listen to it. And now we just watch the meter and I'll tell you what I'm doing on that end. Okay, I'm going to start with this guy over here. It's the one closest to the antenna inputs, which is, just to make sure I've got that right. So the IF transformers for the AM are the, as we're looking at it, the right-hand side, bottom and top, and this one, bottom and top, the right-hand side. So let me start here. Oh, that is going up. But there's a massive peak there. You see, I can't hear what this is, and I'd rather hear it. Even if I put the volume lower, I'd rather hear it. That's very sensitive. That's a peak. Let me put that there just to try and adjust it a bit more. That's very, very sensitive. Okay, that's the bottom IF transformer. Now I've got to do the top. It's going to be difficult to see this, but I'm going to try and see what I'm doing here. This is very, very sensitive. Okay, that seems to be a peak. Let me do the other one. Okay, and now the bottom one. I'm just going to see if there's another peak here somewhere. No, there isn't. Okay, that's the IF transformers. That's the IF chain corrected for 460 kilohertz. I'm going to do this again. Put the volume down. I'm going to do this again because, as you saw there, this thing's very, very sensitive. And trying to do it while looking at or speaking to the camera and looking at the meter is not easy, so I'm going to just do a final adjustment, really peak it up nicely, and then we'll see just how it receives on AM. All right, let's see what it receives like. This is the worst time of the day, so it's the best time to test it. That's the local station. Canary Islands again. Good stuff. Really bad time of the day for AM, but long wave.
Music.
Shortwave. Might get something at this end of the band. There we go. Really difficult to tune because these stations are so close together. This thing really needed a band spread. Of course, as I go closer to that end, there's less reception. Now, what is FM like? Usually when people mess with the screws at the top there, they do all of them. So let's see what FM is like. I have sorted out the gearing on this thing. It just needed some lubrication. And I need to change the antenna at the back because it's for AM. So let's see what we get. If anything, it hasn't been aligned yet. Oh, the voltage is too low. Okay, let me take it off to bulb.
Ali uma noite.
Whoa.
No personagem das Mil e Uma Noites, o Willa Crudi, o objetivo dele.
That is great.
É mostrar de que forma.
The actual RF alignment slightly out. That station there
O objetivo dele é essencialmente
should be at 99. It's at 100. And there's one at 89.3, which I'm receiving at 90. And 88, I'm receiving almost an 89. So this could be just a matter of shifting the dial. The strongest one is this one over here, right? 99. That's, I know, is at 99. So all I might need to do is move the dial pointer to there, because I did mess with that, I know that, and it all might come together without requiring an RF alignment. Let me try that from the top here. It's not easy. Where is it now? That's a little bit. If I can get a bit more, just a little bit more.
Como uma pasticina que é adaptada a cada uma das histórias e a cada um dos momentos. E isso é uma coisa que eu acho que faz esse livro qualquer coisa de
Ah, that might have been too much.
Miguel Garcia Marques estava no seu apogeu literário. Foi certa vez questionado por um jornalista cultural que o confrontava com o facto já comumente aceito de que tinha sido ele, Garcia Marques, em o realismo mágico.
There we go. It's on 99. Now let's see what happens at that end. Now, it still needs a little bit of RF alignment, which I'll do. Yeah, I need to do that. Obviously, you can sometimes correct this by, if the dial pointer, if this is RF aligned, in other words, if you tune to 88 and you're seeing 88, and if you tune to 100 and you're seeing 100, and then you take the dial pointer and you move it a centimeter to the left, right, physically, when you're cleaning the faceplate or whatever, then everything will be out by a centimeter. And that sometimes is all you need to do to RF align this, to correct the correspondence between the station you're tuning to and the dial. In this case, we do need to align a bit. It's a little bit off at this end. This is supposed to be 88. I'm getting it at 87.6 or something. So I'll do a tweak on that. But first I need to do the actual IF alignment of the 10.7 megahertz. I was just getting ready to do the FM-IF alignment, which is my usual routine, which would have been to inject the 10.7 megahertz onto this, which is just a coil. I would normally just put it over the ECC85 and up the amplitude till I heard the tone. I would frequency modulate it with the tone, and that's where I would inject it, and then I would measure the voltage across the discriminator cap, the famous one that blew up or that shorted for me, and so on and so forth. Then I looked at the instructions and I got a bit of a surprise. See, a lot of this is actually pretty straightforward. They tell us to inject 10.7 megahertz. They tell us to set the dial on 100 megahertz, which is all the way to the left. No problem there so far. And then they tell us to detune these and then start tuning them. What you're doing here, these, you see this L94, there it is. So you detune it and you tune it again. L79, you detune it and tune it again. I normally don't even bother with this unless it was completely out of sync. If I couldn't hear anything, then I would do that. But what they're telling us to do, first of all, they're telling us to inject it into the grid of the ECH81, which I normally don't do either. I go straight to the beginning, and the beginning, right, the beginning of the chain is actually in the FM block. So it really starts over here. The signal is produced here. There's actually an IF transformer. There's a couple of coils that you adjust here, and then you have the first, where is it? Not this one, it's this one. The first IF, second IF, and on the bottom you've got the discriminator, or the ratio detector. So you would peak the top one, the top and bottom one, both of these, and then you'd go and adjust you would balance it with the ratio detector side of it, the secondary of that second IF. That's what I normally do. But then I check here and it tells us over here that you set the signal to the stator of the FM front end trimmers, point X. Point X, and I went looking for this point X on the schematic. I couldn't find it anywhere, but I'll get back to that in a second. So what you would do is you inject it to point X and you would peak these guys, 93, 78, and 79. So 93, 78, 79, and 94 is the null point. It's the one that you balance. And they've got this here. I hadn't even seen this. 1, 2, 1. And then, of course, you have to peak these guys as well. You would detune 33, and then you would peak 31, 35, 33 for a maximum. What does this mean? Well, if we look here, they tell us to set a, what is it? So 0 to 10 volts, which means you get a 10 volt voltmeter. They're saying microammeter, 100 microammeter with 100K in series, blah, 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 blah. And this is the null point. And this is where I hadn't seen this at all because I hadn't been paying attention. Let's look at the schematic itself. It tells us a bit more. You see, if I had paid a bit more attention and I looked at the schematic more carefully on this part of the schematic down here, it actually tells us exactly what to do. There are 2 points at the back, C and A, 2 little sockets, and those guys are pretty easily visible. And what you do is you are going to do all the adjustments by measuring at these 2 points, these 2 little sockets. So you don't actually go inside and look for points to measure from. They're all accessible here. And here's the first one. There's A, and you see that from A, it comes down here through 100 microammeter, through a 100K resistor to the chassis. This is just a voltmeter. So you just put a voltmeter across there and you peak it for the maximum voltage. Very, very simple. And where is point A on the schematic? Well, point A is actually this point over here. You see, you're measuring the voltage across that discriminator capacitor, the one that I replaced. You're literally just measuring the voltage across that. As you peak the IF circuits, that voltage goes up. And there's ground. So if you're measuring between point A, which is here, and ground, you're literally measuring the voltage across that capacitor. There's no big deal, no mystery involved. And then they tell us that we have to put these 2 resistors in series from point A to ground. So 200K resistors in series to ground. And you measure with a microammeter, 10 microammeter, from point C to the junction of those 2 resistors. Well, this I've done before. I actually made these 2. This is a 100K resistor, 2 croc clips. And I would normally clip this across that discriminator capacitor and measure from there to another point, which we'll see in a second. So I've already got this. Point A is the same. It's across the capacitor, as you can see. So it's from the capacitor to ground, literally across the capacitor. And you put your microammeter there at the junction of the two, and you go to point C. Now, point C, if I followed it through the chassis, would come to either here, probably not right there, but probably somewhere here, probably after the 100K. I'm not sure. It doesn't make any difference. All you're doing is you're balancing the two diodes in the ratio detector. It's exactly the same way as I've done before, except this guy makes it really easy because it literally gives you two sockets to work with. And the ones you adjust are the FM ones. So 93, 94 is the balancing one, the one for the null point. And what you need to do is make sure that you get zero current. This thing will usually use a center negative or center zero meter. So as you adjust 94, it'll go positive, and then it'll go through the zero negative, and you try to balance it right onto the zero, okay? Now, what do we adjust? We adjust 93, 94 we balance. We adjust 78, 79, so that's the first IF, and again, you're just measuring the voltage on there. And then you go down to, or you go back to the front, and the front is 31, 33, and 35. So it's these guys over here. These others have got to do with actual RF alignment. And they actually tell us where point X is. You see, they tell us to inject it at point X, which is there. They show us point X. And there's actually a little hole there where you put a little wire in there and inject it into that hole, which is absolutely great. Now, where is this? This is the stator of C12. Why are we doing it here? What I usually do is I capacitively couple it to the tube itself by wrapping wire around the coil, rather around the tube envelope, and injecting the signal that way. They're going one step further. They're telling us to put it on that point there. Now you see, this is the oscillator section. This is the RF front-end amplifier, and this is the oscillator section. So what they're telling us to do is put it on here, and by putting it on this point, you are injecting the IF signal, the IF frequency, in a way that doesn't affect the balance of the actual oscillator circuit, and it's the best place to send it into. So you're sending it through here, it's coming out here, then you're adjusting these guys over here, 31, 33, 35. That's the coupling that you are adjusting to get the signal 10.7 megahertz into the IF chain, the normal IF chain, which is over here. It starts at the ECH81. That would be the signal coming into the switch between FM and AM, which is perfect. It makes it a lot easier. So that's what I'm going to do. Okay, I've got things set up. I've got the signal generator connected ground to the chassis over there. The signal comes in here through the little wire to that X point over there. So the signal's going into the point which they indicate we should feed it into. I've got this on FM, obviously. I've got this set to 100 megahertz, which is left of the scale. That's all according to their instructions. My multimeter is all set, ready to go. It's on the 10 volt scale. It's going to be reading minus DC volts because that's a negative voltage that indicates the strength of the signal. And I've got it coming through my multiplier set to, I think it's 5 times at the moment. I'll adjust all these settings as I see fit. I've marked A and C on here. The first set of adjustments, I will use the multimeter, connect it to point A and just peak the voltage. And then at the end, I'll come and do the balancing act with which uses C. But at the moment, this is it. This is the meter coming to the back of A and ground to chassis. So I think we're about ready to go. I'm going to do this one and the bottom one. That is, what is that, 78 and 79, I think it is. Yeah. This top, the bottom one is 94. That's the one we need to balance, so I'll leave that out. So let me do these three, and then we'll move on to the front end, and I'll show you which ones to adjust there. So let's look at the meter. I think you can just see all that. So let's try it. This one here. Very little change, but it's peaked. Try the bottom one. Very little improvement. Very little. It seems to have been quite well aligned. This one. Well, that didn't need much, did it? A bit disappointing. You always like to see a massive change and know you've improved things dramatically, but this is not the case here. So let's see what we have to do on that one there. They tell us to detune 33, which is that guy over there. And then they tell us to peak that one, and then peak that again. So if I detune that, and then I peak these guys, there's no difference. It's practically perfect. No difference. And then peak that. And that's it. That's all the peaking done. Pretty simple. Have I forgotten something? No. All I need to do now is to balance that guy up there. Let me show you how I set up the meter for that. Do you remember what they told us to do? They said connect two resistors in series. Here we are. Between point A and ground, which means from there. I'm doing it on the underside because there's some clips there. And I'll just use this as ground. Now they tell us to connect the meter, the microammeter, between point C and the junction of these two. So point C is that guy over there, and I'm doing it on the underside again. There's one connection, and the other one goes to the junction of these two resistors, which is over here. And across those two ends, I've got to connect a microammeter. Now, I've got something you may not have seen before. This is a meter I've owned since high school. I remember asking my dad for a multimeter, a simple, cheap multimeter for Christmas, and he went and bought this one. It was a very good meter at the time, and it still is. Now, what it has is it's got some very good current ranges. There's all the current, 10 amp, 500, 110 milliamps, 100 microamps, and I've got a 10 microamp range. So that is what I set it to. In fact, I start off at 1 milliamp, just in case, and connect that in there. Now, this is not a center zero meter, unfortunately, because it should be something that starts in the middle there, and then you can go negative or positive and make sure it goes back to zero. But what it does have is a DC reversal switch. So when it goes down, if it's coming down and it's going into the negative range, I just reverse it and it starts going up again. So that's what I do. And let me see what happens. At the moment, we're on 100 milliamps. 1 milliamp. 100 microamps. This thing is pretty much zeroed as it is. It's pretty much set as it is, but let me increase the signal strength just a bit. See if I can get some deviation. Yeah, I do get a bit of deviation. I've increased the signal strength just basically to give you a demo of what happens when we adjust this. Okay, I believe I've got it there. Let me try and show you this at the same time. See, it goes up, goes down, goes the other way, so I can change this. If I keep going down, or rather up, I think you get the idea. The idea is to get it to stop right there on zero. That is perfect, and it was pretty much spot on anyway. This is on the 10 microamp range. That's as accurate as you're going to get. And I believe our FM alignment is complete. The IF part of it anyway. Good. That is a lot more difficult to explain than to do, believe me. I think it's the same with all these steps. Setting up cameras, setting up meters and all that sort of thing. Try not to bump the camera. Try not to forget to use the microphone. I've done that a few times. I have to refilm it. It's the only time I refilm anything. So yeah, okay, that's it. FM alignment, IF alignment, done. AM alignment, the IF is done. Brilliant. Well, let's just see what happened to the FM. I'm already noticing something. There's something here on 100, which I wasn't receiving before. This is a very weak station from where I am. There's 99, spot on, as I said it earlier.
Melhores preços. Não perca esta sexta,
There's
sábado.
another one. Yeah. So my usual strong stations are strong again. And not very much different from just before I did the alignment, because as you noticed, there wasn't that much to do. Right, I can tick off the IF alignments now. Well, folks, I've just been testing this on the workshop speakers. This thing is amazing. That little speaker there didn't have much bass, and this is very bass heavy because the tonal controls are disconnected. You can imagine that everything that has to do with tone shaping is actually outside of this. It's with those switches in the front of the cabinet. And of course, the actual speakers are the ones that come in the cabinet. So this thing is very bass heavy as it is, with no tone controls connected. You might have noticed nothing happens here because this is directly connected to all those tone selectors on the front. But I decided to put this in the workshop speakers, and I am gobsmacked. I'm sorry I can't let you hear it because of copyright. But the other thing I've done is I've extended what you're looking at here. It's on 100, but it's actually picking up 101.6, which is my favorite station. It's the one I usually listen to. So I've stretched the tuning, the alignment to pick up to 102. So I'm getting my 101.6 perfectly there before the end. And I still get my 88 down there. So I haven't lost anything. What it has done is it made all these markings on the dial pretty much useless, but that's fine. I know where I am. Let me see if I can find a voice station. This is all music. This is amazing. Damn, where's the football game when you want one? Okay, I am incredibly impressed with this thing. It is producing amazing sound. It was to be expected. I mean, not that much different from all the other radios. It's got an EL84, it's got an output transformer, it's got some tone shaping. What's the big deal? Well, the big deal here has to do with, I suppose it has more to do with the output transformer than anything else, because when you start differentiating between these radios and that they have the same sort of output stage, the same tube, then the only difference really is the output transformer and the beefiness of the power supply. Can the power supply deliver? And this thing can sure deliver. And other than a whole lot of other advantages on this thing, and it looks bloody great, except I still haven't got that thing, this thing is going to be a winner. I'm going to put Bluetooth on here. I'm going to do all sorts of things because this thing is amazing. I was impressed before, but when I put this on the workshop speakers and I sat there for a while listening to music, it reminded me why I love FM on a tube radio. So folks, that's where I'm going to leave you for today. And in summary, everything is finished on this radio here. What do I need to do? I need to work on that behemoth of a speaker system. It's sitting on the floor there. The cabinet needs to be totally stripped and done up. I'm looking forward to that actually, because that one definitely deserves a Tipton treatment. I'll be working on those speakers. I'll then be able to connect this to the speaker system and show you in the end what the final result is. I've got a feeling there'll still be a few challenges with that cabinet. There always are, but that's the next step. And so I want to thank you for your company. I hope you've enjoyed this. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. Once again, thanks for watching. Bye for now. And most of all, stay safe.